Sometimes I come across a Kotlin project that implements its own utility functions or calls into the Java API for a feature that already exists in Kotlin's standard library. So for today's video, we're going to take a tour through the often forgotten corners of the standard library. We're going to explore 7 features that you might have overlooked or forgotten about. Now, each of these features is part of the common code, so they're available on all target platforms. So let's get started. First of all, if you're still using Java's current time millis or nanotime functions to measure your code's execution time, consider switching to Kotlin's time measurement features. Besides being available on all platforms, Kotlin's timing API uses strong types. So instead of trying to figure out the math to convert between days and milliseconds, let Kotlin do the math for you. You can find the timing features under the kotlin.time package, and when measuring time, you'll typically use the measureTime function, passing a lambda with the code that you want to measure. Instead of returning a long, you'll get a duration object, which is very easy to work with and prints out nicely in the console. Now, if you need to get both a duration and the resulting value from the lambda, then you can use a function called measureTimedValue. And this one returns a timed value object that can be destructured. So the first element here is the result of the lambda, and the second is the duration. You can also convert durations to and from ISO 8601 duration strings, which is great when you need to store a duration in a database field or send it across the wire in a JSON payload. For more complex situations, you can mark multiple time points throughout a process and get the duration of time between any of those time marks. So for example, in this code, I'm marking the time whenever my prime calculator finds a prime number. And so we can determine the duration between any of those time marks. So here I'm showing how long it took to calculate the first 1,000 primes, the first 5,000 primes, the first 10,000 primes. The timing API is pretty slick. If you're interested in learning more about how this API works, you can check out a previous video that I did about Kotlin's timing API. I'll include a link in the description. Now, another feature in the standard library that many of us forget about is the group of functions related to checking preconditions. In many cases, the first line or two of a function just checks the arguments to make sure that those arguments are within the expected bounds. So if you find yourself manually throwing an illegal argument exception when an argument is invalid, consider using the require function instead. Just pass a Boolean expression to this function. If that expression is false, then an illegal argument exception will be thrown, and otherwise things will proceed like normal. You can also provide an exception message as a second argument. Now, this message is passed inside a lambda, so it's only evaluated if the requirement failed. So in other words, when this first argument is false. This avoids wasted work when the requirement was satisfied. So for example, calculating a password score might be an expensive operation, so we would only want to do that when we're actually going to throw the exception. Now, if all you're trying to do is make sure that an argument is not null, then instead of using require with a manual null check, you can use the require not null function. This function has a default exception message that's a little more suited to checking for nulls, and it also returns the non-null value. Now in Kotlin, of course, you should use actual non-nullable types whenever possible, but for those cases where you're getting a value from some external source, like a database or an HTTP request, require not null might be appropriate. Now, instead of checking an argument, you might need to check a property inside the class to make sure that it's in some acceptable state before continuing. And when that's the case, instead of throwing an illegal argument exception, we would normally throw an illegal state exception. For these situations, you can use a similar function named check. And it works the same way, just pass a Boolean and an optional lambda to evaluate a message. And like require, it also has a non-null variant. And then finally, for those cases when you just want to throw an illegal state exception and you want to save a few keystrokes, you can call a function named error. You can pass your error message to this function, or you can pass anything else to it and it'll just call toString on it for the message. So again, anytime you want to check for preconditions of an argument or an object state, require and check could be helpful for you. Next up, let's look at some built-in property delegates. You've probably used property delegates at one time or another, especially if you work on a Jetpack Compose or a Compose multi-platform project where by remember and its variants are pretty common. You might have even created your own property delegates for interfacing seamlessly with backings for key value pairs like shared preferences on Android or the Windows registry. But it's easy to forget that the standard library also includes some ready-to-use property delegate factories. And most of these can be found in the kotlin.properties.delegates object. For example, if you need to take some action whenever a property is changed, there's no need to roll your own property delegate. Just use the existing observable function, which invokes your lambda whenever the underlying value is changed. And there's another function called vetoable, which is similar to observable, but this one allows you to prevent the new value from being set. So if you should only be allowed to change a property under certain conditions, this could be a good choice for you. And finally, you might also have a property that's expensive to construct. In this case, you might not want to build it unless you know for sure that a call site's going to need it. So in this case, you can use the lazy function to initialize the property's value at the point when it's first requested, rather than at the point when the property itself is declared. Note that this one is in the main Kotlin package, so you don't even need to add an import for it. So again, property delegates are a fantastic feature, but before you roll your own, check to see if one of the delegates in the standard library already does what you need. Next up, we've got builders, like collection builders and string builders. In simple cases, we can create collections by calling functions like list of, set of, or map of. But sometimes we need to add elements conditionally. So for example, when building a navigation menu, we don't want to include links for administrative features unless the user actually is an administrator. One way of solving this would be to use a mutable collection like you can see I'm doing here. The problem is that a mutable collection can be modified. Even if you return a mutable collection as a regular collection, like I'm doing up here, you can still cast it back to a mutable collection and modify it. So for those cases where you want an immutable collection, but you still need to build out its contents conditionally, you can use a collection builder like build list, build set, or build map. When you call a collection builder, you pass it a lambda, and inside that lambda, the collection can be modified, but the result returned from the function is a collection that cannot be modified. So in other words, that collection can only be modified inside that lambda. Now, I had done a video about collection builders a while back, so I'll include a link to that video in the description in case you'd like to explore this further. Now, in addition to collection builders, we also have a string builder, and this one is helpful when certain substrings would only need to be included conditionally. So instead of appending to a string multiple times, which can result in performance issues, you can use the buildString function. If you've used string builder or string buffer in Java, then you get the main idea here. And in fact, Kotlin has its own multi-platform implementation of string builder. And inside the buildString lambda here, we've got an instance of that class. So you just append strings inside the lambda and the function will return the assembled string. Next up is Base64 Tooling. If you're still using Java's Base64 encoder and decoder, or if you need this functionality for other target platforms, check out Kotlin's Base64 Tooling in the kotlin.io.encoding package. And this one is experimental, so you'll have to opt into it with the opt-in annotation like I'm doing here. You can choose from the default encoder, or the URL safe encoder, or the MIME encoder, depending on your needs. Encoding a byte array into a string is as easy as calling the encode function. Alternatively, you could encode it into an existing string builder or an existing byte array. Now, decoding a string is also easy. Just call the decode function, which returns a byte array, or if you already have a byte array that you want to load the data into, you can use decode into byte array. And by the way, if you're targeting JVM and you're working directly with an input stream or output stream, you can use the encoding with and decoding with extension functions to wrap the stream with Base64 functionality. So again, there's no need to use the Java API or pull in other libraries. Just use the Base64 features in Kotlin's standard library. Next up, we've got HexFormat. If you need to convert decimal numbers to hexadecimal or the other way around, don't write your own parser and formatter. Instead, you can use the standard library's hexadecimal tooling. Like Base64, this one is also experimental at the time that I'm filming this, but it'll probably meet your needs. As for formatting, you can easily use one of the 2-hex string extension functions, which you can find on byte array, byte, short, int, long, and all of their unsigned counterparts. Now, if you don't like the way that a hex string is formatted, you can also pass an instance of HexFormat to this function. And this object allows you to configure things like casing, prefix, suffix, whether to include leading zeros, separated characters, and so on. Parsing is also just as simple. There's an extension function on a string object named hex2byteArray, which of course returns a byte array. Or if you'd rather parse it directly into a number type, you can use hex to byte, hex to int, hex to long, and so on. And as with formatting, you can provide a HexFormat instance to specify the characteristics that a parser should expect, such as the prefix and suffix characters. So here, since I've got this pound sign before the hex characters, I will set that to a prefix, and it'll parse our string out correctly. Now, I also did a video about HexFormat tooling, and so I will link to that one in the description. Finally, if we look in the Kotlin.txt package, we'll find an object named Typography. And this object contains constants for commonly used extended characters that you'd otherwise have to look up. If you need to add a copyright symbol, just reference typography.copyright. Or if you need a non-breaking space character, it's typography.nbsp. We'll also find left and right quotes. Notice that these are actually curved quotes, not the regular straight double quotes. And we've also got trademark and registered trademark, degrees, cents, pounds, and so on. I find this object is pretty helpful when dealing with non-breaking spaces or dashes of different lengths where you need to make sure that you've got the right one. But for many of the other characters, I usually just prefer to use the raw characters themselves directly in my source code. I find that the typography object is still a good quick way to find the characters I'm looking for, though. I'll just copy the character from the description in the comment and paste it where I need it. It certainly works better than scouring character map on Windows or on Mac. Sometimes I'd hold down the Option key and just mash all the keys on the keyboard until I found the character I'm looking for. So I'm usually faster when I pull up the typography object and find the character I'm looking for there. Well, I hope this tour through the standard library has been helpful for you. Remember, I have created some longer videos that explain some of these features in more detail. So if you're looking for more information about some of these topics, check out the description and I will link to those videos. And before I go, I wanted to mention now that the book is almost complete, I'm gearing up to start some live streams in July. But I need to hear from you. There are Kotlin developers all over the planet, so I need to know what times work best for everyone. So if you haven't already, be sure to fill out this very quick survey for me just to let me know what times work best for you, because I want you to be there. Just click on the survey link in the description, or you can scan the QR code on the screen. In the meantime, keep writing that Kotlin code, and I will see you next time.